Welcome to Unacademy. Good evening, all. Welcome to Unacademy, largest online e-learning platform. GATE. We will be discussing control system engineering, and today's topic is BODE plot. We've been discussing about this control system engineering for semester exams. I welcome you all to this session of BODE plot. So, before getting into this, let me tell you about myself. I am SRAVAN Kumar, pursuing my PhD, and I have 7+ years of experience and mentor more than 5K students and also cracked GATE. In Google Play Store, type Unacademy Learning app as a step one, and you'll get this installation procedure. Install, and if you're opting for CSIR, UGC, if you're opting for other, if you're opting for GATE and ESE, click on this, and if you're opting for Plus, click on this, and if you get into step 5, you'll get the subscription, get subscription, and you have Plus and Iconic both. You can use my code as YSK10 to get maximum discount, and as I told you, you'll get a dedicated mentor for your preparation in Iconic. You have many payment options: डेबिट कार्ड, EMI, UPIs, wallets and net bankings. किसी भी एक को यूज कर आप पे सकते हो, and you can get subscribed to that. And coming to today's topic, we'll discuss root locus problem, one or two problems if possible, and we'll move ahead with the frequency response analysis of BODE using BODE plot. So let's take one problem on root locus. Yesterday we have solved one problem on root locus. Today we'll see one more problem on root locus. Yes, sir. Good evening, sir. Good evening, yes, sir. So we'll take up one problem. Just I'll revise what we have done yesterday, write all the steps that we have to do, and we'll move on to the problem. First step, generally root locus is always symmetrical to real axis. And second step would be in whenever you are given a root locus problem for semester exams, I request everyone to watch this short course on control systems so that will clear all your doubts and prepare for your semester exams well. This will give you a glimpse of every topic in control system so that uh, you can attempt your semester exams and score good marks. So coming to this root locus, second step, we'll find the number of poles and zeros, and we'll find the location of poles and zeros. Location of poles and zeros. I think you are able to remember this. Yesterday we have discussed. Karthik Jilla, good evening, sir. Good evening. Archana Prakash, good evening, sir. Good evening. Yeah, Shivakumar, good evening. So we are looking at the location of poles and zeros, and the third step was location of poles and zeros, finding them. In number of poles and zeros, we'll call them as P is equal to and Z is equal to or Z is equal to, and location we named it as P1, P2 and so on, and Z1, Z2 and so on. Now coming to the fourth one, you can plot or draw a pole zero graph or plot, and on this you'll mark all the poles and zeros. You'll mark poles and zeros on this pole zero plot. It has to be actually drawn on a graph, and we will look for the existence of root locus on real axis. Where does the root locus exist on real axis? And we shall see the number of asymptotes that are required, and then we'll find what are the angle of asymptotes. I'll write all the expressions, and we'll also found yesterday what is a centroid. We also need to find take away points, and we have we can find breakaway and break-in points, and we should find angle of arrival and departure, also intersection of root locus with j omega axis. So as I told you, you may or may not sorry, you may or may not have to find all these, because it depends upon the given question again in root locus. These are the different terms. We'll write the expressions are required for these. Let us say now number of poles. Number of poles we'll write it as p is equal to, and number of zeros we'll write z is equal to. Similarly, location of poles as p1 is equal to and p2 is equal to, and location of zeros as z1 is equal to and z2 is equal to. Vignesh Chari, good evening sir. Good evening. Swapna, hi sir, good evening. Good evening Swapna. Now these are some of the things that we write, and we need to know number of asymptotes. Number of asymptotes is equal to this, you need to know, this is p minus z, and angle of asymptotes is is equal to 2q plus 1 into 180 degrees by p minus z. This is how you find angle of asymptotes. And for centroid, we'll denote this centroid by sigma, that is equal to sum of real part of poles minus sum of real part of zeros, because you may sometimes get an imaginary part even, by sum of real part of poles minus sum of real part of zeros by p minus z. And in order to find breakaway point or break-in point, we consider 1 plus g of s into h of s is equal to 0 as the characteristic equation. Determine k from it, differentiate it with respect to s, and make it equal to 0. You get the values of s. Substitute this back into this k. If it is a positive value, you can either you can identify directly. Anil Kodabaina, good evening. Rajkumar, good evening. Mahesh Kusuma, good evening, sir. Good evening, Mahesh. Muhammad Rais, good evening, sir. Good evening, Rais. If it is a positive value, you can say that is a valid breakaway point, and if it is a negative value, it is an invalid breakaway point, or by inspection also you can do that. So these are some of the formulae, I mean, for root locus while doing a problem or solving a problem that you need to remember. So let us consider one problem. Yesterday we have taken one, and today we'll take up the second example. And let me give you first what we have done yesterday. Then yesterday we have taken some example as q of s is equal to k by s into s plus 2, I guess. This was one of the example. I think some of you remember this. Rajkumar, your class very nice. Thank you, Rajkumar. Explanation is very good. Mahesh Kusma, thank you. This was one of the problem. Today what we'll do is we'll add a pole to this and we'll see what is the effect of adding a pole to a root locus. So let us add a pole to this. Pole is the denominator part. So I'm adding 1 by s4. This. Yesterday we have taken g of s. Now today we have taken g of s. G of s is equal to k by s into s plus 2 yesterday. Now we are taking k by s into s plus 2 into s plus 4. This is the question. K by s into s plus 2 into s plus 4. And the question asked is sketch root locus. Let us say the question is asked is something like this: sketch root locus. And I want you guys to give me some answer based on this. Yesterday I have told you first step is root locus is symmetrical to real axis. This is what a general step that we write in your exams also you need to write. And I want you to tell this: what are the number of poles and zeros? Number of poles is equal to and number of zeros. I'm waiting for your answers. Number of poles. Bunny, nice class, sir. Thank you, Bunny. Good evening, Bunny. And I want you guys to tell me some answers for this. Number of poles. What is that? What are the number of poles? Madhavi, good explanation, sir. Thank you, Madhavi. And can you guys? I'm waiting for your response. I want you to tell me what are the number of poles, number of zeros. What is the number? What are the number of poles and number of zeros? Krishna Chari. Good evening, sir. Good evening, Krishna. Welcome. Welcome to Control Systems Crash Course. So number of poles is denominator roots. See, you have one s here. This is s plus 2. This is s plus 4. Number of poles are 3. Hope you are able to understand this. And in the numerator, if you have any s terms, that will be zeros, but you don't have any. So this is 0. So Chandrakiran, good evening, sir. Good evening, Chandrakiran. Vishnu Pulaga. Good evening, Vishnu. Welcome, welcome to. Yes, Mahesh. So number of poles are 3 because you have 3 terms in the denominator and you don't have any s term in the numerator. So z is equal to 0. Now just tell me what are the location of poles. Where are the poles located and where are the zeros located? Because you don't have any zeros, so we can say we can cancel out this. You don't have any zeros, right? So now what are the number of poles? Me number of poles are 3. Where are they located? Where are these poles located? See, you can make this denominator equal to 0, s into s plus 2 into s plus 4 equal to 0. So you can say s is equal to 0 is 1, s is equal to minus 2, s is equal to minus 4. So the poles are located at P1 0, 2 minus 2 and P3 as minus 4. So these are the 3 different values where poles are located. We need to draw a pole 0 plot. Let us consider one pole 0 plot here. I'll draw it in the next slide so that will be easy for us. I'll draw a bit big. This is the vertical axis, or you can say it is a j omega axis, and this is the real axis. So let us consider these real and imaginary axis. So this is imaginary axis, this is a real axis, this is negative real axis, and this is positive real axis, and this is negative j omega. And let me mark some values Let me mark 1, 2, 3, 4, 5, and 6. Let me take this as 1, 2, 3, 4, 5, and 6. Right? And this will be plus j omega j1. So this is j2, this is j3, this is j4, and j5. And let us consider this as minus j1, minus j2, minus j3, minus j4. Hope you are with me. Right? Now, where are the poles? Let us look at the poles. One is at 0, P2 is at minus 2, and P3 is at minus 4, and poles are represented by a cross mark. So let us represent 0, minus 2, minus 4. So let us represent them as 0. At 0 there is a pole, and these are minus 2, minus 3, minus 4, minus 5, negative real axis, right? So at minus 2 you have other pole, and at minus 4 you have another pole. We have total 3. Mahesh, good evening Mahesh. Alkuturi Mahesh, good evening. So these are the location of poles. This is negative real axis, this is the origin. These are the positive real axis 1, 2, 3, 4, and these are the negative minus 1, minus 2, minus 3, minus 4, minus 5, and minus 6. And we have poles at origin minus 2 and minus 4. So we have represented cross mark at these places. This was the third step, location of poles and zeros and pole zero plot. Plotting the poles and zeros on the graph. Yes, sir. Yes, yes, sir. Now, and what we have to do then, we have to check for existence of root locus on real axis. For the existence of root locus on the real axis. Now, how do you check that? Yesterday, I have told you that in the previous session, I have told you that root locus will exist if point if to the right of that point there are odd number of poles and zeros. If you are at this point, let us say at this one, the right you don't have any poles and zeros, so this is not a part of root locus. Even if you are at this point, till this point you don't have anything. If you are at this point, let us say minus 1 or just beside the 0, all these will be, if you look at the right, you have one pole, that is you have odd number, so this part will be a part of root locus. So this is a root locus path. This is a root locus path. And now if you are at this point or at this point, any of these points, if you look at to your right, you have only 2 that is even. So this will not be a part of your root locus. Again, coming to this after minus 4, if you are at these points, no confusion, sir. Different colors selection, sir. Thank you, SR. So all these point, if you look, any point after this minus 4 till minus infinity, you have t, t poles. So this every part of this is a root locus. So this will be a locus again. So this will be a root locus again. This is a not root locus in this between minus 2 and minus 3. And yesterday I told you that if you have two poles adjacent to each other and if there is a root locus existing between them, there will be a takeaway point. We'll look at this afterwards after doing some of the points again. So we have done this fifth part also. What was that fifth part? It is finding the existence of the root locus on the real axis. Then yeah, then we should calculate number of asymptotes. What are the number of asymptotes and how do we do them? I'll just tell you number of asymptotes. So number of asymptotes. What is the expression for that? It is p minus z. What is p? 3. Z is 0. So number of asymptotes are 3. What are these asymptotes? Asymptotes are straight lines that if the path to the root locus which are tending at infinity. See, because we have 3 poles and there are no zeros in the given question, we assume that all the zeros are at infinity, and these three poles require some path to tend to this infinity where the zeros are present. So we require this asymptotes. Asymptotes are the straight lines, and they have to be drawn on this, have to be drawn on this graph, but we do not know where these have to be drawn. That's the reason we will find something called as centroid. Thing called as centroid. What is centroid? Is equal to sum of real part of poles minus sum of real part of zeros by sum of real part of poles minus sum of real part of zeros by e minus z. Let us see what are the, see, you don't have imaginary parts in this. You have 0, minus 2, minus 4. So sigma is equal to 0, minus 2, minus 4, sum of real part of poles, and you don't have any zeros. E minus z is 3, so it is minus 6 by 3 will give you minus 2. What is the centroid? It is minus 2. Let us represent this on this. So this part is a centroid. Let us call this as centroid. What is the centroid? Centroid is the point of intersection of asymptotes. Centroid is the point of intersection of asymptotes. That means all these straight lines must be drawn from this point. It's minus 2. But how we need to draw? How many lines we need to draw? We know that there are three. Three lines have to be drawn. How should I draw them? Should I draw them like this? 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 We do not know that. In order to find that, we require what is called as angle of asymptotes. What do we require? We require angle of asymptotes. It is theta is equal to 2q plus 1 into 180 by p minus z. So because we have three asymptotes, so we take q is equal to 0, q is equal to 1, and q is equal to 2. So let us find theta 1, theta 2, and theta 3 corresponding to that. So what is theta 1 is equal to 2 into 0 plus 1 by minus z is 3 into 180. So it is 180 by 3 is 60 degrees. Now theta 2, if you are taking 2 into 1 plus 1 by 3 into 180 is, I want you guys to tell me, 2 plus 1, 3 by 3 is 180 degrees. Simply. And theta 3 is equal to 2 into 2 plus 1 by 3 into 180 will give you 2 2s are 4 plus 1 5, 300 degrees, right? So 300 degrees. So these are the angles. So what are the angles? Theta 1 is equal to 60 degrees. Let us use some different color. Let us use some different color as this. What is theta 1 is equal to 60 degrees, theta 2 is equal to 180 degrees, theta 3 is equal to 300 degrees. So with these angles, we need to draw three asymptotes where at minus 2. So let us take that. So this is that. So let us use this protractor, and at these minus 2, we need to draw three lines with angles 0 degrees. So this is 1.60 degrees. With minus 2 as the centroid, you need to draw three. One is 60 degrees, this point. The other one is 180 degrees, this. And the other one will be 300 degrees. Rotate this and place it at this point. And this is 180. 180 plus 120, so this point will give you, this is 300 degrees. So draw straight lines. So draw some straight lines from these points as these lines. So this is part. So this is 60 degrees line. We'll use green color to this 180 degrees line, and we'll use, so this is 180 degrees line, and this is 300 degrees line. So these are the three asymptotes. This is 300 degrees line, this is 60 degrees, this is 180 degrees, and this is 300 degrees line. I think you are able to understand this. Now, with this, because you have two asymptotes, two asymptotes with 60 and 180 degrees, you have two poles at these points and a pole at this point is tending to infinity. So we have found these three angles, 60, 180 and 300, and we have drawn three asymptotic lines with 60 degrees, 180 degrees and 300 degrees. After this, because we have a breakaway point in between these two, 0 and -2, you have a breakaway point. We need to find what is the breakaway point. So let us find what is breakaway point. Ninth step would be finding breakaway point. How do you find that? We need to consider g of s is equal to a by s into s plus 2 into s plus 4, and write 1 plus g of s into h of s is equal to 0. That is, you get s into s plus 2 into s plus 4 plus k equal to 0, and find k from this. When you write k is equal to, you'll get, let me take that directly. So k is equal to, get s cube plus 6s square plus 8s, negative sign. Differentiate this and make it equal to 0, you get 2 points. S is equal to minus 0.8 and minus 3.15. These are the two values that you get, and when you see, breakaway point must be between these two, 0 and -2, and by inspection we can say that this is a valid breakaway point and this is an invalid breakaway point. This is a valid breakaway point, this is an invalid breakaway point, because at this point you don't have any root locus. So what is the breakaway point? It is negative 0.8. So at this 0.8, graph will break and it will move along this line. So let me draw in the other slide more. So we have taken the horizontal and vertical axis, and we have marked the poles and zeros. So this is -1, -2, -3, -4 and -5. We have poles at origin -2 and -4, and we have found that root locus will exist between, I'm just repeating everything for your sake, we have root locus between these, and this was the centroid. So this was the centroid, this is the centroid point. Is you need to draw three straight lines with three different angles. So I'm drawing three angles. One is, let this angle be 60 degrees, and this angle be 180 degrees, and this angle be 360 degrees, and we have got 0.8 as the, this was the centroid, right? This is centroid. Where is the centroid? at -2, and this is the breakaway point. Breakaway point. So at this breakaway point, what is the breakaway point? It is negative 0.8. So this is a valid because you have a root locus between, because we had a root locus between these 2 points also here. So this is the breakaway point, means the root locus start from this pole and start from this pole and travel to this point and travel to this point and move along this asymptotes, move along this asymptote. Now it is intersecting the j omega axis, it is intersecting the j omega axis, and we need to find this point of intersection of the j omega axis by using RH criteria, by using RH criteria. This can be below this asymptote or it can also be above this asymptote. That depends, or that will be found by using the asymptote. Good explanation, sir. Thank you, Swarna. Harshita. Yes, sir. Good explanation. Thank you, Harshita. So let us see. So this was the about breakaway point, and now we need to find. Now we need to find. We need to find how do we get the intersection intersection of root locus with a omega axis. You need to, you already know 1 plus g of s into h of s is the characteristic equation, and it is s cube plus 6s square plus 8s plus k is equal to 0. And yesterday already we have discussed how do we find these things. I'll just take this to the next slide once again so that that will be easy for us. Yeah, so this is finding the, now first we need to write s cube, next s square, s power 1 and s power 0. Write this odd coefficient first, 1 and 8, 6 and k. Then you get what is that, BC minus AD, 8 6 are 48 minus k by 6 is a 0. And to find this, what do? You take 6 6 as A and k as B, as C and this as D, and you'll say BC minus AD is 0, IC this is K. So from this you can find, in order to 48 minus k by 6 is greater than 0, 48 minus k is greater than 0, k less than 48, or k marginal value is 48. At this point, if you substitute k is equal to 48 here, this row will become all zeros row. That is, it is giving you the roots on the imaginary axis. So you take k is equal to 48. So this equation, you need to consider the equation above that equation. So the auxiliary equation will be a of s is equal to 6s square plus 48 is equal to 0. So 6s square plus 48 is equal to 0. So s square is equal to minus 48 by 6. So s is equal to, you'll find it. So s is equal to s or minus j, 8 6 are 48, right? So it is root 8. So you can also write it as 2 root 2. So this is the point root j root 8 plus j root 8, and this is minus j root 8. Now this is the complete problem. This is how you'll do this, and we should compare this with the previous problem, that is uh, the one that we have obtained yesterday. We have obtained something like this. Yesterday we have got the answer like this. This was the root locus yesterday. So this was the root locus yesterday problem, and here the g of s was k by s into s plus 2. This is problem yesterday, and if you compare these two, in this, when we have added a pole here, root locus has started shifting. Root locus shifted right when when we add a pole. Therefore, stability decreases. Stability may decrease. So this is the point that you need to understand. That's the reason I have taken this problem. Satish Kumar, very very clear explanation. Thank you, Satish Kumar. Lavanya, good explanation, sir. Thank you, Lavanya. So this is all about the root locus problem. Now we'll see a plot. This is a semi-log sheet, semi-log graph. So you need to know this semi-log graph in order to or this BODE plot. So before that, let me take what is frequency response analysis. Frequency response analysis and tell you what is that. Till this point, hope everything is clear. Discuss frequency response plot and I'll start BODE plot. Then we'll see problem probably if today, if not tomorrow, we'll try to discuss a problem on this BODE plot once again. So what is a frequency response analysis? Frequency response. So frequency response analysis implies it is varying the varying frequency omega from 0 to infinity and identifying what is the magnitude and phase angle of a function f of s or f of j omega. Whenever a system, whenever you consider system is excited by a sinusoidal, the output is also sinusoidal, but the only difference is if it is a sine t, it would be b sine omega t plus phi, and if it is also omega t, means an LTI system. Manikanta, yes sir, very good explanation. Medha Reddy, thank you, good explanation sir, thank you. So input is sinusoidal, output is also sinusoidal. There is a variation in magnitude as well as phase angle. There is a variation in magnitude as well as phase angle. So frequency response analysis is varying the frequency from 0 to infinity and observing or finding the magnitude and phase angle of the system, or magnitude and phase angle of the response. Let us take one example. You'll clearly understand what exactly it is. So let us say there is a system which has some x of t as the input, and let us take that x of t is equal to sine t, and y of t is the output of the system. So what is y of t that you need to find? Right? So let us take x of t is the input the system, and the system has, let me consider this as the system. This is the output. Let us say this is 1 by s plus 1, this is sine t, and this is x of t is equal to sine t, and let us say we are in need of finding y of t. So let me take this to the other slide. So this is x of t and y of t. I'm going to find what is y of t. So what would be y of t? Shweta Chinni, good evening sir, good evening, thank you for joining me. So what is y of t? Y of t is equal to, y of t is the output and function is f of t. And how do you find this? First let us consider the function f of s. This is a function f of s equal to 1 by s plus 1, and replace this frequency with s is equal to j omega. S is equal to j omega, so 1 by j omega plus 1. So what is f of j omega? It is, so find magnitude of f of j omega is 1 by under root of omega square plus 1. What is the phase angle of f of j omega? It is, first is 1 plus j0 we can consider. So tan inverse 0 by 1 is 0, and this is tan inverse omega by 1 is omega. What is the magnitude at frequency is same? So at omega is equal to 1, what is the magnitude of f of j omega? It is 1 by root 2. What is the phase angle of j omega? It is minus tan inverse 1 is minus 45 degrees. What is the output? Y of t is equal to, you can write it as 1 by root 2 sine t minus 45 degrees. What is the input? X of t is equal to sine t. Now if you observe these two, what is the magnitude here? 1. It is 1 by root 2. The phase angle 0 degrees. It is minus 45. That means whenever it is excited by a sinusoidal, it is output is also sinusoidal. The only difference is you have a difference of magnitude and phase angle. You have a difference of magnitude and phase angle. Good evening. Now let us take the response of second order system. That is the frequency response. Frequency response of a second order system. Now let us consider the standard second order system. We already know C of s by R of s is equal to omega n square by s square plus 2 zeta omega ns plus omega n square. Now I'll take common in order to write it in time constant form. We'll take omega n square by, if I take omega n square common, it is s square by omega n square plus 2 zeta s by omega n plus 1. If you still write it, you can cancel out these two and can write it as 1 by, and substitute let us say this is f of s function, so I'm writing s replaced by j omega frequency response. So here if you substitute j omega square, it is minus omega square by omega n square plus 2 zeta a omega by omega n plus 1. Can I write it as 1 by 1 minus, taking 1 to this side, 1 minus omega by omega n whole square plus j 2 zeta omega by omega n. I'm separating real and imaginary parts. So this C is real part, this is real part, this is imaginary part. So I'm separating imaginary part because I want to find the magnitude and phase angle. So what is the magnitude of f of j omega now? Magnitude is 1 by under root over 1 minus omega by omega n whole square plus 2 zeta omega by omega n whole square. Soumya, good evening. So this is the magnitude. We also have to write the phase angle. So let's write the phase angle. First we'll write what is f of j omega was 1 by 1 minus omega by omega n whole square is j 2 zeta omega by omega n. We have written magnitude. Now we are writing phase angle. So it is 1 plus j0. So it is 0 degrees by tan inverse of 2 zeta omega by omega n by 1 minus omega by omega n whole square. So this is the phase angle. Now let's plot, you just plot the graph between magnitude versus frequency. you'll get a plot like this. This would be the plot, and this is magnitude of f of j omega versus frequency. This is the cutoff frequency, and this is a resonant frequency, right? This is 0.707. If you just take this magnitude and substitute omega is equal to 0 and omega is equal to omega n and omega is equal to omega r and so on, if you substitute, you'll get a graph something like this. And you can approximate this as that is, now we'll see what is a straight line approximation. Straight line, because we are drawing it on a approximation, straight line approximation. If you are looking at the straight line approximation, let us consider the magnitude that we have written. What was a magnitude in dB? Why we are writing in dB? Because BODE plot is the plot of, writing it, BODE plot is the plot of dB value of magnitude of f of j omega versus frequency and phase angle of f of j omega versus frequency. This frequency is log omega. Although it is written as log omega, that indicates it is being taken on a logarithmic graph. That is the reason we'll take the dB value. So the dB value of f of j omega is written as 20 log mod of f of j omega, which is minus 20 log. If you observe this, modulus, if you take this term to the numerator, it will be whole term minus 1. So this is, if you log m power n is equal to n log m. So that's how you get log magnitude log of 1 minus omega by omega n whole square plus 2 zeta omega n by 2 zeta omega by omega n, zeta omega by omega n whole square, and this is under root. This is under the root. For the time being, we'll neglect this part, 2 zeta omega by omega n, which is a very high frequency value. So we'll just neglect it for now and take under root of 1 minus omega by omega n whole square, which will cancel out this square, and you will get minus 20 log 1 minus omega by omega n whole square. With this, we can find the straight line values at lower and higher frequencies. Krishnachari, understanding, sir. Thank you. Chandrakiran, nice teaching, sir. Thank you, Chandrakiran. Srija Reddy, explanation. Nice explanation. Thank you. So from this, you can find would be the magnitudes at 0 and lower and higher frequencies. Let us consider low frequency. When the frequency is very low, if you can say the frequency is very low, we can say that in these two terms, 1 minus omega by omega n whole square, I'll assume that 1 is very much greater than omega by omega n because it's a frequency which is very less, low frequency. So the magnitude value will be, let us consider magnitude as a minus 20 log 1, which is 0 dB, 0 decibels. And if you consider the high frequency, let us consider a high frequency. At a high frequency, you can say omega by omega n is much greater than 1. In that case, a value will be minus 20 log omega by omega n minus whole square. So this is something like a y is equal to mx. This is something like a straight line. y is equal to mx. See, so hope you are able to Krishnachari understanding, sir. So this is a straight line. We have understood that this is a straight line, and I'll try to draw that. Now if you take the straight line approximation, this is the magnitude versus graphs. So first in low frequency, this is the frequency. At a certain point we have got in low frequency, the graph was a straight line with 0 dB. Let us take this as 0 dB line. Let us take this as a 0 dB line. So this as a 0 dB line, this point. And after that we have seen there is something minus 20, or if you take this 2 to this side, it is minus 40 log omega by omega n. Minus 40 log omega by omega n. So it is negative slope. So this can be this part. So and the frequency at which this variation, and the frequency at which is a change of this slope. So this is a 0 dB line, and this is a minus 40 dB line. So and the frequency at which this will happen and this change of slope will happen is called as a corner frequency. It's called as a corner frequency. Manikanta, explanation excellent, sir. Thank you, Manikanta. Let's see once again. I'll just review what we have done. I have told you what is frequency response analysis, that is varying omega from 0 to infinity, and finding if you give any input, a LTI system sinusoidal input, output is also sinusoidal with a change in magnitude and with change in magnitude and phase angle with same frequency. So we have taken one example and tried to prove that there is a change in the magnitude and frequency of the response. And have taken the response of the second order system. We have considered standard second order system and tried to write in terms of a, this is time constant form basically, in time constant form, and then we have written what is magnitude and phase angle and a plot of magnitude versus frequency. In order to approximate it to straight line, we have taken the straight line approximation. Because the BODE plot is generally taken on the logarithmic graph, we are trying to find the dB value. And dB value, when you find it for low and high frequencies, it is a 0 dB for low frequencies and minus 40 dB or minus 20 dB based on the given question. So you have got these two frequency ranges. Low frequency, this is low frequency range, and this is high frequency range. So this is what happens, and this is generally a low frequency and high frequency ranges. So we have got a 0 dB and minus 40 dB. So these are the straight line approximations of the magnitude in decibels. So this is a dB, magnitude in dB of the magnitude of f of j omega. Now, so generally I would like to add something now to this. So BODE plot has plots. One is magnitude plot and phase angle plot. So the magnitude plot is finding the magnitude of f of j omega versus log omega. We'll plot it. We'll vary omega from 0 to infinity, and we'll find angle of f of j omega versus we'll vary this omega and try to find the phase angles. So that will look something like this. There are some points that I would like to add to this. Plots, if they are drawn on a single line, that would give you on a single graph will give you a very good picture of what is going on. Magnitude is something written as mod of f of j omega in dB, and this is considered as the 0 dB line reference, and here minus 180 degrees is taken as the reference. So this magnitude plot is generally a straight line approximation, something like this, or you can get the different graphs. And this is a phase angle graph. This is magnitude plot. This log omega and this is log omega. Magnitude plot and this is phase angle plot. These are the two plots. Saurla Madhavi, teaching super sir. Thank you. Thank you, Madhavi. So from this, you need to know some of the terms like gain crossover frequency, phase crossover frequency, which are useful for the stability analysis. Now, how do you find the stability from a BODE plot is? Now we have seen how do we make this straight line approximation, what is magnitude and phase angle of second order system, and also frequency response analysis. We are exactly entering into what BODE plot is. BODE plot has two plots. One is the magnitude and the phase angle plot. We'll find the magnitude and vary omega and find the magnitude values. And in phase plot, we'll find the angle of the given function and vary frequency and find the different values of angles, and we'll plot them like this. See, when you vary omega from 0 to infinity and find the values of magnitudes, let us say a1, a2, a3 and so on, you'll get this graph. And whenever you try to find angles as theta 1, theta 2, theta 3, what are this theta 1? It is for omega 1 and omega 2 and omega 3. You'll get a graph like this. From this, we need to analyze the stability of a system. And how do you analyze the stability of the system from these two plots, magnitude plot and phase plot? Is you need to know some of the terms, that is gain crossover frequency, gain crossover frequency, and phase crossover frequency. Gain crossover frequency and phase crossover frequency. Once you know this, you'll understand how to find gain margin and phase margin of the system. So we will look at this gain and phase margins in the next session. But today I'll just tell you what are gain crossover frequency and phase crossover frequency. Now, what is a gain crossover frequency is? It is the frequency which magnitude of g of j omega into h of j omega or f of is 1, or in dB it is 0 dB, and it is denoted by omega gc, gain crossover frequency. And phase of crossover frequency is the frequency at which phase angle of f of j omega or g of j omega into h of j omega is minus 180 degrees. Now if you look at these graphs, this is a 0 dB line. So this plot will intersect this 0 dB line at some frequency. These are the frequencies. So when you look at this graph, you'll understand these are the different frequencies. This frequency at which magnitude plot will intersect the 0 dB line is called as the crossover frequency. And the frequency at which this phase plot intersects the minus 180 degrees line is called as the phase crossover frequency, omega GCF and omega PCF, omega GCF and omega PCF, phase crossover frequency and gain crossover frequency. So with this knowledge of gain and phase crossover frequencies, we'll be able to find gain and phase margins. And when we find this gain and phase margins, we'll be able to tell about the stability of the given system, which we'll discuss in the next session or a special class. Thank you all. Thank you so much for joining me today. I hope this was a useful session for you all. And be live with me every day so that you'll complete the control systems crash course. This is a semi-log graph sheet. These are the frequencies. These are 1, 2, 3, 4, and so on. Because we are taking dB per decade, we'll take one. If you can also start it from 0.1, and this has 1 and 10. I'll just tell you this in whenever we solve a problem. And thank you all. Thank you for joining me today. This is India's #1 study channel, Creatrix Great. GATE Unacademy, GATE Unacademy, GATE CE, Unacademy, GATE Telugu, Unacademy SSC JE, Unacademy Computer Science, Unacademy GATE Questions, Unacademy Electrical Junction, Unacademy Engineering Foundation, Unacademy Pathshala, and of course Unacademy Semester Exams. you can join us on http colon double slash t.me slash creatrix 8 on Telegram, and you can use my referral code for maximum discount on Unacademy subscription. Please do like and share and subscribe to our channel and click on this bell icon. Thank you all. Thank you once again for joining me today. This was a useful session. Thank you.